Deep in your app there's a space filled up by a great database. It's tables where information goes, made of cells inside columns and rows. To speak to it, we can connect using insert, update, and select. With a language that has no equal, we need more people to try SQL. SQL!
Welcome to Try SQL. My name is Kari Clark and I look forward to giving you some key points on how to use the database programming language known as SQL. This course is designed to teach you the basics on how to read, write, and program in the database language known as SQL. Let's begin with Level 1, Section 1, Understanding Databases. So the story begins with a question. We want to see a movie at the Gatsby Theaters, but we're only interested in seeing comedies. How can we get the titles of all the movies that are comedies, and what can we use to get those? Of course, we could use the local newspapers, but there are so many reasons that make this not the most convenient tool to use in today's society. Instead, we could look at a website for reviewing current movie listings and runtimes. With today's technology, the biggest difference in these two forms of media is that only one of these can be continuously updated, while the newspaper will remain static. This makes the use of the web much better in keeping up-to-date information about almost anything we wish to find out. But what is it exactly that makes a website stay updated? Well, this is because it's being updated by a database. A database collects and organizes information so that it can be easily retrieved. For example, the movie listings website goes to a database to request the most current showtimes for its theater. Believe it or not, databases are used in most of the technology that we use every day. And many different services such as email, GPS, Facebook, our cell phones, Twitter, and websites also use databases in some form or another. We will be using a database to solve some of these problems that we will encounter in this course. The database that we'll use is called the Gatsby Theaters database, which has all types of information. But how is all this information, such as movie info and showtimes info, organized? Our information, or data, is organized into what we call tables. A table holds the data that can be used in a database and allows for it to be easily retrieved. The database holds 4 tables: movies, concessions, showtimes, and promotions. So here's a question. In order to look up information on movies, we would need to go inside which database and look inside which table? As you can probably see, we would need to go inside the Gatsby Theaters database and look inside the movies table. This is where we can find our information. Now, let's go a little deeper and find out what's inside the table. We see the data from the website, but not quite in the same form. What we actually see is the same data stored and organized into what's known as cells or fields, where each cell holds a separate value that can be accessed by a website. These cells for each table are organized into rows. Basically, a row represents an entire data record within each table. For example, we can look at the first row of data as having an ID of 1 with the title of Metropolis and a genre of sci-fi, along with having a duration of 153. Each row is separate from the next. A table is also made up of columns, which hold similar data for each separate value. Each column is given a descriptive name which describes the type of data that can be found in it. The 4 columns we have are ID, title, genre, and duration. Often, a table will have some unique identifier, which is used to order the rows. Another name for this is the primary key of the table. Let's look at how to find some data in our database. Say, for example, we want to find the value Nosferatu. How will we find this value in our table? To move through a table in a database, we should first look at the columns. We'll start with the ID column. Since there are no matching records here, we move to the right 1 column to find that the matching record is in the title column. Next is to search by row. Let's move through each row in the column of title and find Nosferatu. We find that Nosferatu is in the title column and on the second row. Generally, tables will contain fewer columns than rows. So, while a table may have over 1 million rows, it may have only a couple of hundred columns. The search path first moves through the columns from left to right, and then we search the rows from top to bottom. That's all we have for section 1. Now let's look at some challenges to help reinforce these concepts.